and geographical studies of various kinds are built, right? It's also worth noting that this kind of knowledge about soil, vegetation, climate, precipitation is the kind of knowledge of which agencies like the Soil Conservation Service and a lot of agencies in colonial settings as well sort of set about authorizing what they did, right? They knew what was right because they had this information, and therefore you should listen to what they had to say about how you should farm, for example. Now, there's a potential circularity in this, and that circularity was actually built in to the theories about vegetation and ecology in the early 20th century, theories that in many ways were incorporated into those agencies and the policies that they perpetrated, right? So if climate plus soil equals vegetation, then the vegetation that you see has a certain kind of fixedness, right? You think of the soil as basically a given in a given place, unless you've lost it due to erosion. You think of the climate as basically a given in any given place, although that's no longer something we can assume or take for granted. And therefore, you think that the vegetation is pretty much determined for any given place, and that's what it is. That's what will naturally grow there. And the theory associated with Frederick Clements of climax, plant communities, is precisely that kind of theory. He says quite explicitly, if you know the climate and the soil, that's what determines the climax. And the climax is the natural state of that plant community. And that is what it will always tend towards if you disturb it or if it experiences some kind of disturbance, because the climate and the soil stay the same. So you can plow it up and plant something else there, but if you walk away and leave it alone, eventually it will return to its climax condition because that's just the way it is. And Clements himself actually devoted a lot of his energy to using plants to infer climate. Much of his work in the Western United States was an attempt to figure out what could be planted agriculturally in different parts of the West without, and figuring out how you could predict that so you wouldn't have farmers going in and planting a whole bunch of crops that turned out not to grow there. And that type of information rested on this idea that from the plant community you could figure out the climate and the soil and therefore the natural conditions and what will and will not grow there. And again, it implies stasis. This coincidence is actually predetermined by the theory of climax and succession, and there is the possibility that in fact it won't obtain in a given place. That for various reasons was overlooked in a lot of cases. So why does this matter? The problem is that there is good reason to believe that at least in certain contexts it's not about just climate and soil. There are other important determining factors as well, fire being one of them, and by extension human beings being another one. And that's where we're headed here when we start thinking about pine. But this is from Carl Sauer in 1950, well ahead, before Dale and Carter, well ahead of pine. Carl Sauer being an incredibly famous Berkeley geographer, and he wrote this and published it in the Journal of Range Management of all places in 1950. The more we learn of climatic data, the less success there is in identifying climate with grassland. A drift of vegetation toward more grassland has been going on for many thousands of years. This deformation has probably derived its driving force from fires, chiefly a cultural phenomenon. And by that he means chiefly about people, not about nature. Sauer was, as I said, sort of ahead of his time in recognizing this, and he's casting this at an evolutionary timescale. He's essentially saying, and I mean, we all know humans evolved, we believe, in savanna settings. In many ways, the sort of origins or the moment of appearance of humans is somehow related to the moment in which we ostensibly climbed down out of the trees and started walking erect through the grasslands, right? Grasslands have got this very fundamental sort of relationship to humans in an evolutionary sense. Sauer is saying humans have been a driving force in the spread of grasslands historically and prehistorically. That we somehow fit with grasslands, and the reason we fit with grasslands is that we bring fire with us. We burn vegetation, and in burning vegetation, we favor grasses because grasses are better adapted to withstanding fire than other kinds of vegetation, such as trees. Pine, Stephen Pine, how many of you have heard of Stephen Pine before? Only a handful of you. Really interesting guy, really worth looking at more of his books if you're interested in this subject. Environmental historian with a background in fighting forest fires for the U.S. Forest Service. And he has done a great deal, almost single-handedly, resuscitating this line of reasoning that you can trace back to Sauer and thinking about the relationship of people to fire. He got started obviously thinking about forest fires, wildland fires, but he has pushed it around the world and into a whole bunch of other realms in ways that are really fascinating. He also happens to write really well, which is helpful as well. What about fires in human societies have inserted fire into every conceivable place for every conceivable purpose, and they have done so for so long and so pervasively that it is impossible to disentangle fire from either human life or the biosphere. So he is essentially, and it's true, Homo erectus, which preceded Homo sapiens, is dated in an evolutionary sense to the moment at which, as far as we understand, our ancestors figured out how to control fire. And the argument evolutionarily is that made that much of a difference. It altered the course of human evolution. And okay. And if this is the case, it raises some very interesting questions for that human environment, nature, culture dichotomy or dualism, right? I mean, in a sense, if you can't understand humans without understanding fire, if fire is something that makes humans possible in an evolutionary sense, then you have to try to decide whether fire belongs on the nature side of things or on the culture side of things. And it becomes very difficult to decide, right? This, I guess, is not very surprising, the notion that fire mediates between soils and plants. The simple story in which plants grow and die and decay and decompose and create soil and it goes on like that, basically is not complete. And this isn't only true in some minority of the world's terrestrial systems. It's actually true in most, if not all, of the world's terrestrial systems. Pretty much anywhere you have plants, fire, at least sometimes, plays a role. this is a point that might sound a little far-fetched, but if you read Pine and you actually start thinking about it, it's still the case. Even if fire only makes its appearance every like 100 years, it still plays an important role, and it accelerates the process of decomposition, obviously, and can be very important in forming soil. You think about the Great Plains of the United States and the 6 or 7 feet of topsoil that we built our prosperity on. That's the result of a system not only of lots of incredible prairie grasses growing and decomposing, but also burning on a regular basis. It becomes an ecological wild card in a sense, precisely because humans can start fires, but fires can also start on their own, right? Lightning can start fires in many of the world's systems, given the right circumstances. In some parts of the world, lightning will start fires almost every year. On the other hand, so they can be natural or humanly caused. They can be intentional or accidental. They can encourage, depending on the system you're in, a variety of different kinds of vegetation. As a gross statement, grasses are better adapted to fire than trees. But it's not the case that there are no trees anywhere that are adapted to fire. There are trees that are adapted to fire. There are forests that are adapted to fire. It can accelerate or retard soil formation and erosion. And preventing it from happening can be as important an ecological manipulation as causing it to happen. So it really, really complicates any kind of simple mechanistic explanation that you might want to construct about the relationship between people and plants and soils. Because it's going to be there in one shape or another, but it's not going to be there in some kind of simple way that's the same everywhere. I want to introduce the concept of disturbance regimes. For those of you who are in ecology or environmental sciences, this is perhaps completely basic information. We can think about fire and make sense of fire as a disturbance. And disturbance regimes, it's a term that Pine uses, are a useful way of thinking about plants and plant communities and their relationship to natural processes and human processes. Any given disturbance, and by this I mean it can be any number of things: fires, floods, hard frosts, storms, droughts, grazing, plowing and clearing, insect blights, pests of various kinds, volcanoes. So these are things that can be either humanly triggered or caused or naturally occurring. What they are is disturbance, moments at which vegetation gets disturbed in some way. And frequently it means that a lot of vegetation dies or burns up, even if the underlying plant does not die. And we can think about disturbances in a number of basic ways. We can think about them in terms of their frequency, how often they occur, their intensity, how severe they are, their timing, when they happen in a given year or in relationship to other climatic patterns. We can think about how big they are, their size, and finally we can think about the context, the larger ecological or evolutionary context in which they occur, the conditions of the vegetation, the history, the climate before and after the disturbance occurs. And this is a useful sort of metric or matrix within which to think about any disturbance, because these different factors or variables can cause what looks like the same disturbance to have very different outcomes depending on these attributes. Okay? So the example I'm most familiar with, southwestern desert grasslands. You have a situation in which you're working with about 10 to 16 inches of precipitation a year. That can vary widely. You can get very, very little. You can get 4, 3, even 0 inches. You can get a lot more, 20, 30 inches in a given year. You have wet summers and winters and very dry springs. Extreme lightning incidents in the late spring before the rains arrive, some of the most frequent and intense lightning storms in the world. You have periodic droughts. And what this results in is recurrent fires anytime between about April and October. And they are particularly pronounced if you have a year when you get tons of rain and tons of vegetation grows, followed by a year when you get very little rain and that vegetation becomes extremely dry. And the next lightning strike, you can get huge numbers of fires very quickly and easily. If these systems burn, you get a grassland. The grasses will recover from the fires and thrive. If these systems stop burning, they turn into shrublands. And here's a picture. This is southern Arizona. This is actually a prescribed burn. It was set on purpose. And you can see in the background, my pointer has stopped working because my battery's not strong enough anymore. I'll see if I can get, yeah, there it is, barely. Anyway, in the background, you see mesquite trees, which have invaded this grassland over the last 150 years because of fire suppression. And in the foreground is an area that was actually bulldozed. The mesquite trees were removed with a bulldozer, and the grasses came in. It's actually a non-native African grass. And you need to keep burning it periodically to keep the mesquites from taking over again. So all of this is an elaborate way of saying Clements and the idea of climax being vegetation being determined simply by climate and soil failed to think about fire, or adequately think about fire. Clements certainly thought about it, but he didn't see how far it undermined his larger theory. And by extension, failed to think about humans. And there are abundant evidence and research and still some debates about exactly how many of the fires in the Southwest were caused by humans versus lightning. And at the end of the day, it sort of doesn't matter, because either way, you had the conditions for fire, fire happened, and you had grassland. Overgrazing and fire suppression have resulted in shrubs. So there's essentially two climaxes, which is to say there's no climax. That's the wrong way of thinking about it. And fire and people are the mediating factors that disrupt that nice, tidy system of thinking about vegetation. So where are we going on with all of this? We'll take a break in a few minutes. Implications. Humans are active agents in the evolution of plant communities. And that's true not just where you see people actually plowing and planting, right? You can't understand plant communities without thinking about and understanding the role that humans have played in shaping and influencing them. And you can extend that to other organisms, although we're not going to bother to try to do that right now. So there's no such thing as pristine vegetation understood in the extreme version of somehow untouched by people, and therefore purely natural and unaffected by this thing called culture. This is true of wild as well as domesticated plants. Pine makes the point that early agriculture was as dependent on fire as wild vegetation and vegetation communities are, right? Fire to this day is an important part of agricultural practices in many parts of the world. It's a tool for restoring soil fertility, or in fact creating that fertility in the first place before you plant in some systems. And therefore, the advent of agriculture does not in any way change the importance of fire. In some ways, it just accentuates it. In other words, plants, animals, soils, and humans have co-evolved for each other, mediated by fire, for approximately 500,000 years. Now, yeah, let's take a 5-minute break, and then we'll come back. Okay. So, I'll come back to the point of coevolution in a moment. But first I want to stop and draw out some of the points that Steve Pine develops in the chapter that we asked you to read for today. He calls this the transition from flame to furnace, which maybe is a little bit coy or cute, but nonetheless, there is something here worth thinking about, particularly in relationship to climate change. Okay? The Industrial Revolution, viewed through this lens of fire, is about the shift away from biomass burning towards fossil fuels, right? From organic carbon to fossil carbon, essentially, as the primary energy source for society. Pine makes the case, and this may sound odd, I mean, given how much attention is sometimes given to the phenomenon of fire in tropical forests like the Amazon as an agent of deforestation. Pine's case, and it's a very persuasive one, is that there's actually a whole lot less vegetation burning, organic carbon burning fire today than there was 500 years ago. And if you look at the United States, the case is particularly extreme. Basically, the entire continental United States, with the exception of very high mountains, at one point in time was subject to fairly regular burning. It covers the entire Great Plains and large parts of the Southeast, and on less frequent intervals, the forests of the Northeast and the upper Midwest, as well as the West, which, as we know, still burns to this day. And he suggests that this shift was the most fundamental restructuring of anthropogenic fire and global fire regimes since the Neolithic, which is to say, since the advent of agriculture, since the development of human civilization itself, as we think of it. Okay? Internal combustion, right, which is what the Industrial Revolution comes from, in a sense. I mean, internal combustion is the energetic driver of the Industrial Revolution, displaces wild or biomass burning, and shifts the ecological index for thinking about fire from soils to air sheds in the atmosphere. This is Pine's argument, right? So if previously we could think about fire and its effects principally in relation to soil and soil formation and subsequently on plants, now he suggests with internal combustion we have to think about it in terms of the atmosphere. The atmosphere is integrating at a global scale effects that had previously been considered local or regional. And this is in fact the case, right? The atmosphere mixes all of the emissions of CO2 from all fires, both internal combustion and biomass, and contributes them to, or rather in the atmosphere, they then contribute to a global scale climate system in a way that is essentially indifferent to the source, right? A CO2 molecule from a forest fire or a grassland fire has the exact same effect on global climate as a CO2 molecule from fossil fuel. Industrial combustion burns with savage indifference to fire ecology, without regard to time of day.